Okay, now let's determine when this is equal to 0, or f prime of x is equal to 0. Let me take out the 4x. So 4x times x squared minus 1 is equal to 0. So x equals 0, x equals 1, x equals -1 are all those critical points we're going to look for. Now I'm going to calculate the second derivative, so I can use the second derivative to determine which of these are relative minimums and which are relative maximums. Okay, the second derivative is the derivative of the first derivative. So let's look at this. This is now 12x to the second minus 4. Now let me consider each of these locations to compare the second derivative. So let's start with 0. If I plug in 0 here, 0 minus 4 is -4. And I really just care that this is less than 0. Let's try 1. 12 minus 4 is +8, which is greater than 0. What is that? Still positive 12 minus 4, which is also +8, which is also greater than 0. Okay, now let me use this information to determine which of these are relative minimums versus relative maximums. Okay, so let's look up here. If it's a relative maximum, the second derivative is negative because that makes it concave down, which means that point must be at the top, which makes it a relative maximum. So there's a relative maximum at, and see, the second derivative was negative for this one, positive, at x equals 0. Okay, because I need to give two reasons why when I'm using the second derivative. Okay, the first reason is because f prime of 0 equaled to 0. And the second reason is because the second derivative was negative. So f prime of 0 was equal to 0, and the second derivative of f at 0 was less than 0. Okay, so the other points are relative minimums. At x equals 1 and -1. The reason is, I need to give both reasons. The first one is because if I do f prime of 1, that equaled to 0, which was the same as f prime of -1. The other reason is because the second derivatives of both of them were positive, meaning it was concave up, meaning that must have been a minimum. And f second prime of 1 was greater than 0, and f second prime of -1 was also greater than 0. So second derivative test, first derivative equals 0, and then the second derivative is positive or negative, which is telling me whether it's a relative minimum or maximum. Okay, let's try another example. It says use the second derivative test to find the relative extrema of f of x equals the square root of 2 times x minus 2 cosine x on the closed interval 0 to 2 pi. Okay, so first thing, I'm going to do the first derivative. Just be careful here. This is root 2 times x. The x is not in the radical. So if it's root 2 times x, the derivative is just root 2. The derivative of -2 cosine x is +2 sine x. Okay, let's see when this is equal to 0. Okay, so I want to find the x values when sine of x is equal to -√2/2. I am limited to the closed interval 0 to 2 pi. Sine is the y coordinate, which is going to put me down here and down here. So that's going to be at x equals 5 pi over 4 and x equals 7 pi over 4. Okay, let's go ahead and check the second derivative and see if that will tell us which one, if these are relative maximums or minimums. Okay, so I'm going to take the derivative of the first derivative. The derivative of root 2 is 0. Derivative of 2 sine x is 2 cosine x. Okay, and then I'm going to evaluate the second derivative of 5 pi over 4 and 7 pi over 4. So f second derivative of 5 pi over 4 is 2 times the cosine of 5 pi over 4. The cosine of 5 pi over 4 is over here, which is negative root 2 over 2. Okay, which is actually negative root 2, but I really just care whether it's positive or negative, and I can already tell that that's going to be negative. Okay, now let me consider the second derivative at x equals 7 pi over 4. So 2 times the cosine of 7 pi over 4. Cosine of 7 pi over 4 is over here, so that's going to be positive root 2 over 2. And remember, I only care whether it's positive or negative, so even though this is positive root 2, I care that it's actually greater than 0. Which means if you forget your trig values, you could determine whether they're positive or negative even if you're not sure of the exact value just by looking at the quadrants in this particular case. Okay, now let's consider both of these. Okay, the second derivative was less than 0 at 5 pi over 4, which means this is concave down. If it's concave down, it must mean that at x equals 5 pi over 4, it's a relative maximum. Okay, so there's a relative max. X equals 5 pi over 4. And the reason is because f prime of 5 pi over 4 was equal to 0, and f second prime of 5 pi over 4 is negative. Make sure you give both reasons. If you only give the second reason, you're just telling that it's concave down. You're not actually giving any justification for it being a relative maximum. Okay, now the second derivative at x equals 7 pi over 4 was positive. Since it's positive, it's concave up, which means this must be a relative minimum. Okay, I'm going to say the first derivative equal to 0. And the second derivative at 7 pi over 4 was positive, and that's how I determined that it was a relative minimum. And that's my justification for the second derivative test. Okay, now one more piece of information they want to give you. If there is only one critical point, and it is a relative extreme, then it's also an absolute extreme. Okay, now remember the second derivative test only applies on an open interval, which is why we're not worrying about the endpoint. So if there's one critical point in the middle, it happens to be a relative minimum, well, it must be an absolute minimum as well. Okay, let's do the second derivative test and just see what happens here. So let's do the first derivative first. Okay, this is product rule. I'm going to make that my first, that my second function. Okay, first derivative of the second derivative of e to the x over 4 is e to the x over 4 times the derivative of x over 4, which is 1/4, times the second times the derivative of negative x, negative 1. I'm going to rewrite this before I simplify it. What is that? Negative x over 4 times e to the x over 4 minus 1 times e to the x over 4. Okay, I'm going to set this equal to 0, and I'm going to factor out the e to the x over 4, which will leave me with negative x over 4 minus 1, and I'm setting it equal to 0 to find the critical points. Now let's see, e to the x over 4, let me make that equal 0. Now e to the something, it can never equal to 0. Even if I put a negative value in for x, it's going to make it a fraction. It's not going to make it equal 0. So this equation has no solution. So let's solve the other one. So I get x equals negative 4. So there's only one critical number here. Okay, so let's do the second derivative to determine whether this is a relative minimum or maximum, but because there's only one critical number, it would also mean it's an absolute minimum or maximum. Okay, let me do the second derivative. let's see. I think I'm actually going to take it from this step. I could do it from this step, but this one's kind of set up for the product rule. So let me do it from this step. If I do it from that step, then the first function is e to the x over 4. The derivative of this is negative 1/4 plus the second times the derivative of the first, and then times 1/4. Okay, now the only critical number was negative 4. So my question is, do I simplify this first or just plug it in? Let's just plug it in and see what happens. So the second derivative at negative 4. So that's going to be e to the negative 4 divided by 4 is negative 1 times negative 1/4 plus, so that's going to be negative 4. So positive 4 divided by 4 is 1. Oops, minus 1 times e to the negative 4 divided by 4 is negative 1 times 1/4. Okay, let me look at this. I'm really just trying to determine whether this is positive or negative. Okay, so let me rewrite this first expression. That's going to be the e to the negative 1 really just puts it at the bottom. So this is negative 1 over 4e. Now 1 minus 1 is 0. So if I do 0 times this side this, it's just going to go away. Okay, well that's definitely negative. Since it's negative, then this is going concave down, which means that's going to be a relative maximum. But because it's the only critical number, it's the only relative maximum, which means it's actually the absolute maximum. So the best way to describe it is that there is an absolute maximum at x equals negative 4. And the reason is because f prime of negative 4 equal to 0. And because f double prime of negative 4 was less than 0.